I'm Phil, and in this video, we're going to continue our course on robotics. So we go on to session 3, which is other projects. So we just open that up. And the demand for this came from the students who wanted to do more than just robot projects. And most of the content of the course explores programming and electronic interfacing that's not just for robots. They can be applied to many other projects. So here's just a few examples that we'll do in this session. We'll look at traffic lights, garden control, security systems, and related to security systems, we'll also add home automation. We'll do rubbish detection, and a couple of special ones where we look at using OpenAI voice assistant for the Atom computer. And finally, we'll look at some music programs. So there'll be 3 videos for this session. We'll do traffic lights for the first one. Then the second one will be garden control. And the third one will be security systems. And we'll say a little bit about the other projects also in that video. So in traffic lights, we're going to look at a couple of projects. Well, the first one is a very simple one where we just add neo pixels to our Atom computer. So let's go and have a look at that one now. So the idea is we'll just close these other tags, and here we're going to just have one post for our traffic signals with 3 lights. We've got red, yellow and green, and they'll all be in a north-south orientation. And the design, we're going to use SK6812 LEDs. And to access a particular LED, we use the index in our software. And we're going to interrupt everything 2 minutes to change the cycle. So we're not going to follow the exact specification for traffic lights because we're going to identify red, yellow and green as separate phases. But in reality, the yellow and the green share the one phase. So the hardware, we're going to use the Atom S3R, and we'll add to that a unit called the RGB LED. We'll use some Lego components to mount them, and the connections will look like this. So on port A, we use a Grove cable that connects to the RGB LED unit. Now we might have a look a bit of the software. So the first thing in the software is that we have to set up the internal hardware. That is, we're going to access the button, and we also need the timer. So the external units that we're adding is the RGB, and they're going to go on ports GPIO 1 and 2. So if we look at the software, it's quite simple. We'll just bring it up. And here's our software. So right on the top left, we're setting up our timer that will give us interrupts every 2 seconds. And after that, we're initializing the RGB unit. Initially, it's only going to show a color blue. We're going to set the phase to 0, and we're going to have 3 phases. So in the main loop, we simply increment the number of phases, starting off with phase 1, and we call up the function set phase 1, and that sets a green. If we go to phase 2, we go to red, then we go through the transition on phase 3 via yellow, back to phase 1 again. So a very simple program. And the callback allows us to change the phase by 1 every 2 seconds. So quite a simple program. So stay tuned and we'll have a look at the results of that. So we're able to set the timing, and in the future we'll actually adjust the timing um, so that we don't have the yellow equal to the red and the green. Okay, so hopefully we'll be able to transition to more accurate traffic lights so that we can comply gradually with the traffic signals design manual in the RMS manual. In our next example, we're going to look at traffic lights 11, and just opening that up and closing down all of the other routines. Our desktop setup is this one, where we've got mounted on a Lego post and a Lego base, a north-south and an east-west set of traffic signals. Both of them have red, yellow, green, and we're also going to use a LCD on the Atom computer for our pedestrian control. So if the pedestrian makes a request, they press the button on the Atom computer, and that will show the status. Don't walk if it's not pressed, and it will say walk only when the north-south goes into a green phase, and it will show red. So that's our desktop arrangement. And the objective here is that we're going to have 3 phases. Our north-south phase, east-west, and we'll have a pedestrian with countdown, and we'll show the countdown on the screen, and the pedestrian has to activate that phase with the push button. We're going to use phases and a subphase, similar to the RMS traffic manual, where we have the yellow included in phase A. We're going to set the timing. The red will be 4 units, yellow 1 unit, and green 3 units. So the yellow and the green equal the red in this case. Design-wise, we're going to use the SK6812 LEDs, and they'll be accessed with an index again in software. We'll be using a timer interrupt of 2 seconds, and we'll show the subphase on one of the labels on the LCD. Hardware-wise, we're going to use the Atom computer, the RGB LED unit from M5 Stack, and we're going to use 2 of those in this arrangement that I've got here. So from port A, using a Grove cable, we connect to the Grove socket, and then at the other end, we connect the other Grove cable to the second RGB unit. Each of those RGB units has 3 LEDs that correspond to our traffic lights. Software-wise, this is what our software looks like. And we'll go across just after this segment and have a look at that software in detail. So we were able to get that to work. I was able to achieve all the results. We set the timing for our traffic signals, and we complied with the design requirements that I set. So we might go across now and have a look at the software. So if we go across to our Chrome browser and go to the M5 Stack website, we select UI Flow 2, and I've programmed our traffic signals program with 2 posts, a north-south and an east-west direction, and a pedestrian phase. So we've got 3 phases here. On the extreme right, on the top left rather, we've set up the program. Under that, we've got our callback, and we've got another event timer or an event uh, function, and that's for button A, and that's where the pedestrian, if the pedestrian wants a request, we set the pedestrian request to true. Then we have our loop, and on the right, the first column is for our north-south, and you can see each of the phases that are down here as we change the signals. And we're showing the colors on the RGB unit and also on a circle that we draw for our pedestrian status on the Atom computer. The next column is for our east-west direction. So if we were to actually examine that in a little bit more detail, on the left, we've got our UI interface, and we've painted that using the extended program where we can grab the title and the labels and the circle to draw onto the Atom computer. And under that, we set up our software, which is, we're not setting anything special on that one, but hardware, the internal hardware, we're going to use the push button on the Atom computer and the timer. They're the two essential ones. And the additional units, we're setting up let's have a look. We go down and we've got the RGB. There it is there, RGB, and that's going to be on GPIO 1 and 2. So that sets everything up, and we're ready. Let's have a look at the software in a little bit more detail. We'll just zoom in. There we go. We've got that a little bit easier to see now. So on setup, we set up a new timer, and we're also initializing the RGB for 2 units. We've got the index from 1 to 3 is used to access the red, yellow, and green for our first post. And the other post, which is the east-west, is going to use an index from 4, 5, and 6. And we're going to set up our timer to give us an interrupt every 2 seconds. We initialize all the RGB units, and we then set up our phase parameters. The circle is for our pedestrians, and that's drawn onto the Atom. Under that, we've got the callback for our timer, and that every 2 seconds, it changes the subphase by 1. So the units of timing here are the subphase unit. Under that, we've got the function for our press button A, and that sets the variable pedestrian request to true. And that's handled in the main loop. So the main loop updates our subphase on the label, and if then we go through depending on what the subphase is. So we're going to show a don't walk for pedestrians, and if the subphase equals 4, we then show what that subphase is by calling the phase 4 function. If it's phase 5, and if it's a pedestrian request, we will show a green for the pedestrian and a walk for the pedestrian. If it's the last phase or subphase, and we then change the pedestrian to don't walk, And we then have our colors for the different signals. So this column is for the north-south, and we have phases 1 to 3, phase 4 or subphase 5 and 7, and phase 8. So as an example, the first one will show the red and blank out the other two lights, but will show a red also for the pedestrian light on the atom LCD. The other ones are all identical. The northwest, but we don't have a pedestrian one there, so we cut out the circle. But the other ones are quite similar. And we have to make sure all of this is synchronized and we don't get a conflict of colours and directions for pedestrians and traffic. And that's the code for our traffic signals for 3 phases on the Atom computer using RGB and the LCD on the Atom computer. Here is our traffic signals using the Atom S3R computer, which is just here. This is the Atom computer, and we've got the north-south aspect here, and as we turn it around, we've got the east-west aspect, and we're using also modules or units from M5 stack for the RGB lights. So the lights change according to the timing for the phases, and we've also got a pedestrian push button. So when I press this button, it will put in a request for a walk clearance or a walk sign, and it's on now. And it's going to show you the countdown time. And that's traffic signals using the Atom S3R computer. In our final traffic signals program, we're going to use the puzzle unit to give us a little bit more control over how the traffic signals look like on our posts. So let's go and have a look at what that looks like on the desktop. So here's a setup for our traffic signals using the Atom computer and the puzzle unit. So we have a post right on the top, which is showing green on this one, but it also gives an arrow indication for traffic turning left. And it can change colours from green to red. And the other colours come up. And each of these is using a special display called the puzzle unit. And each puzzle unit has an 8x8. So we've got 64 LEDs in the one puzzle unit. And we've got 4 puzzle units on this one traffic signal post. So let's have a look at what the objectives are here, and we'll just increase the size of the font. So we're going to design and construct a single set of traffic lights, north-south, and we'll also have a turn left indicator. We'll look at the RGB recommendations. We're going to use 4 puzzle units. And hardware-wise, we're going to continue using the Atom computer. The puzzle unit, as a matter of interest, we're going to use 4 of those. And we're going to connect physically the puzzle units, the ones which are in the vertical sequence, that is the red, yellow, and green. We're going to use a chain bridge connector that will provide both physical and electrical support for our puzzle units. So they're all actually linked in a sequence. The one on the bottom, that is the green, is connected to the arrow using a chain return. And that does the same thing. It provides physical support, but it also provides the electrical connections. We use Grove cables. Well, actually, we only need one because we're using the chain bridge and the bridge connectors for the other connections. Software-wise, we might go and have a look at that in detail. The UI, we set up our puzzle as the unit that we select, and that will be on the GPIO 1 and 2. Code-wise, well, this is what our code looks like, and we might go across and have a look at that in detail. We're able to achieve all of our results, and there are plenty of extensions you can have a look at for this. You could add some sound for the pedestrian, for the user interface, you give them a bit more feedback. And that concludes all the projects for our traffic signals, but we'll go through the code for that shortly. Okay, so some challenges for your own projects. You might like to consider 4 sets of traffic lights on the same road and design and coordinate those with a wave and with offsets for each of them. And that's getting closer to the Sydney Coordinated Adaptive Traffic System called SCATS. You could use AI for age recognition and allocate more time for seniors. You could do something similar for weather and allow for more stopping time. Use AI to count the number of pedestrians waiting at signals. And if there's a lot of pedestrians, perhaps give the pedestrians a bit more priority. You could also give buses priority. So if a bus is coming, then it could get a pass-through on the green and give it more priority at the traffic signals. And that concludes our traffic signals projects, but stay tuned for a desktop demonstration. To get the puzzle units to work with the Atom computer, we're using UI Flow 2, and you call that up from the M5 Stack website. So go to Software and choose UI Flow 2, and this is the software for our demo program. So we might actually start off with the UI. We've got nothing on the UI this time. And if we go down, we're not calling up any additional COM software. And hardware-wise, there's very little extra. We're not actually using any of those commodities at all. Units, no base, but we are using the puzzle. And we're going to use 4 of those. There's the puzzle there. And we just scroll down and you select the puzzle, which is near the bottom of the list. So we keep on going down until we get the puzzle. So the puzzle's selected, and it's going to be on GPIO 1 and 2. Okay, so we might go and have a look at the software in detail. We'll start off with the top left. We'll just zoom in so you can see the code. And there's not much happening on setup. We're just selecting the puzzle, and that's already, once we've selected it from the units on the left, it automatically inserts this column. But we have to change the 1 to 4 because we have 4 puzzles. And in our loop, we're going to go through all of the different orientations of red arrow, red, green. Then we're going to go to the green left arrow, the red left arrow, the yellow, and the red. And we go through that sequence by calling up the different functions. So the numbers that we've got here, this is all for red. So if we want the red phase, we've got the sequence of red on top, yellow, and green. And you can see the pattern is the same, but all we do is fill in, or we paint the LED array or pattern on the screen here as part of our program. So that's for red, yellow, and green. And if we want our arrows, we just simply paint those arrows for Unit 4. And each of these will call up. So when we go to green left arrow, it only corresponds to the Unit 4, whereas the other ones are actually corresponding and switching off the other aspects of our traffic signals. And quite simple, that's a demonstration of traffic signals with an arrow using the puzzle unit on the Atom computer. Here we have the M5 stack computer, the Atom S3, and it's hosting puzzle units. There are 4 of them. These are the puzzle units, 1, 2, 3, 4, and they're acting as traffic signals. The Atom computer is on the right, and we could also use its screen to assist with our traffic signals. And the arrangement of the puzzles is combined with 2 chain bridges. The first one's a chain bridge, which is this one. It comes in a packet of 10, and it connects 2 puzzle units together. And the other one connects them horizontally. So it's called the chain return, and it connects just across. So these 2 are using the chain return, and the vertical ones are using the chain bridge. And here you can see the traffic signals in operation and changing colours and giving directions to our left arrow.